Hi Algebra 1, today we're going to tackle the GCF. Well, if we go to our notes, first thing it talks about is the GCF. GCF stands for the greatest factor that divides two numbers. So we're looking for the greatest common factor. We abbreviate that GCF. So if something is asking you to find the GCF, it's saying, well, what's the highest number that goes into both of them? So if I have 12, let's talk about numbers that multiply to get us 12. We've got 1 and 12, we've got 2 and 6, and we've got 3 and 4. Okay, well, there's the factors of 12. Now let's talk about factors of 16. Well, what multiplies to get us 16? We've got 1 and 16, we've got 2 and 8, we've got 4 and 4. Well, if we look here, we can see that each one that they have in common, we've got 1, they've got 2 in common, and they have 4 in common. So if I were to find the GCF for this problem, my greatest common factor, I would say, is 4, because 4 is what they have in common, and it's the largest number out of them all. So that's kind of the concepts that we're working with, but we're going to dive a little deeper into this kind of GCF. So if I look at number 2, it kind of gives me the steps over here, which is nice, but let's kind of break it down. So we've got 4. What numbers multiply to get us 4? We got 1 and 4, and we've got 2 and 2. Okay, now let's look at 6. Well, what numbers multiply to get us 6? We've got 1 and 6, we've got 2 and 3. So now we've got to figure out, is there a common variable between the two? So we've got an x and we've got a y. So there is no common variable, so I'm not going to be taking anything out. But I will be taking out a number because I see that they have 2 in common. So I'm going to take out that 2 and I'm going to put it outside parentheses, and then I'm going to write what's left over. So how to figure out what's left over is you're taking the original term and dividing it by what you're taking out. So if you look at 4x, we're dividing that by 2. Well, 4x divided by 2 gives us a 2x. And if we look at the original, we've got 6y. Well, we're taking 2 out of that, so that's going to get us a 3y. So here's our answer for this. And if you were to go back and distribute that 2 through, you would get the same thing as the original problem. So that's kind of the concept of GCF. You're simplifying it so we can dig deeper into the actual problem of it. So let's look at number 3. So we've got 6, 9, and 12. Well, if we look at 6, 9, and 12, I know that 6 is 2 times 3. I know that 9 is 3 times 3. And I know that 12 is 3 times 4. Well, I've got a 3 here, 3 here, 3 here. So I'm going to take out that 3. The next thing I've got to look at is my variables. So I have x to the third power in my first term. Well, that's like having 3 x's. So I've got 1, 2, 3. In my second, I have x squared. That's like having 2 x's. And in my third one, I just have 1x. Well, what do we have in common? We all have an x term in it. So I can take 1x here, 1x here, 1x here. So I'm going to put an x with that 3 because that's what our GCF is for this problem. But next we've got to figure out what's left over. So we're taking out a 3x. We got to see what's left over. So if we do 6 divided by 3, 6 divided by 3 gives us 2. But we're not done because we also have to look at the variables. We have 3 x's to start with, but we take out one of them, so we have x squared left over. So there's our first term, done. Now let's do our second term. We've got 9 divided by 3. That gives us a negative 3. We have x squared, but we're taking out an x, so we have x left over. So our middle term is minus 3x. Our last term, we have 12. We divide it by 3. That gives us a positive 4. Well, the term has an x, but we're taking away an x, so you're just writing a 4. So your answer here would just be 3x and then 2x squared minus 3x plus 4 in parentheses. And if you were to distribute that 3x through, you would get the same thing as the original. Okay, so let's try that one more time, just in case I'm blowing your mind and you're still confused. So if we look at 16 and 8, we've got 16x squared, which is 2x's. Then we've got minus 8 and then 1x. Well, numbers that multiply 16, we've got 1 and 16, we've got 2 and 8, and we've got 4 and 4. Numbers multiply 8, we got 1 and 8, and we've got 2 and 4. Well, our GCF for our number we can see is going to be 4 because that's what they have in common. So I know I'm going to take a 4 out. Next thing I'm looking at are my variables. So my first term has 2x. My second term only has 1x. So I can see that I could take away 1 from each of these. So I'm going to have an x out here with my 4. Then I got to figure out what's left over. So I've got 16x squared divided by, so 16x squared divided by 4x. Well, we know that 16 divided by 4 gives me 4. Then I've got x squared, which is like writing xx. Well, these cancel out. I have 1x left over. Then I've got my minus 8x, and I'm dividing by 4x. Well, negative 8 divided by 4 gives me a negative 2, and these x's cancel out. So here's my answer. The work I showed down here is only how to find what's left over in parentheses. So if that's what's confusing you, this is the work that I'm showing. But let's go ahead and practice that again. Shocker, another example. All right, so I'm not going to list out all the factors for this one, but I want to start thinking about kind of knowing them off the top of my head. So if I look at 15, 30, and 45, what would all of those numbers have in common? Well, they're all multiples of 5, so I could take a 5 out. So I've got a 5 out of parentheses. Well, now I'm looking at my exponents. So my first term, it has x to the 7th. So that means I have 7 x's on there. So I've got 1, 2, 3, 4, 5, 6, 7. Okay, my second term has 6 x's. So I've got 1, 2, 3, 4, 5, 6. And then my last one has 3. 1, 2, 3. Because it's x to the 3rd. Well, I need to figure out what they have in common. So if you look, we have 3 x's in the first term, we've got 3 x's in the second term, and we've got 3 x's in the first term. Okay, so that means I can take out 3 x's, but I write that x to the 3rd. Well, now I have to figure out what's left over. So I've got 15 divided by 5. That gives me 3, and I can see that I have 4 x's left over. So x to the 4th. Then I have 30 divided by 5. Then I have 30 divided by 5. That gives me 6 that I'm going to put here. So plus 6, and I see that I have 3 x's left. So that's x to the 3rd. And then lastly, I do negative 45 divided by 5. Well, that gives me a negative 9. And then I can see that I don't have any x's left over here. So I just leave it at 9, and there is my answer. Keep in mind, if you were to distribute that negative 5, or not negative, if you were to distribute the 5x to the 3rd, you'd get the original equation. All right, let's do this one more time, and this one is a little different because it's already kind of in factors, which we'll learn more about that here shortly. So if I'm looking at this, let's just break it off into 2 different parts. Well, let's find the GCF of 9 and 12. Well, a number that divides 9 and 12 is 3. So then I got to figure out what's left over. So 9 divided by 3 gives me 3x. And then I've got 12 divided by 3 gives me a plus 4. And then my second one, I'm looking at 4x and 16. Well, we know that 4 divides both of those numbers. So we would have x plus 4 left over. But we still have to condense this and combine the two GCFs. So 4 times 3 gives me a 12, and then parentheses, my leftovers, I've got 3x minus 4, and then x plus 4. And that is my answer. It seems a bit confusing, but it's just keep on practicing, keep thinking about GCFs, and see what you can take out. All right, so we are done with notes for today, so go ahead and check off our notes for our booklet and give the practice a shot. See you later.